Hello. Let's talk about colligative properties. Colligative properties are those properties of solution that are affected solely by the amount of solute dissolved, but not the identity of the solute. Basically, it's things that are affected by how much you dump in, not what you dump in. The more you dump in, the more it's affected. But anything will do. Dumping in more of a solute that's an electrolyte will affect the amount of current that a solution can conduct. However, being electrolytic is not a colligative property because it does matter what you dissolve. If I put in salt, I'll be able to conduct electricity, but if I put in sugar, I won't. So being electrolytic is not colligative. Colligative properties are based solely on how much is dissolved, not what is dissolved. How much, not what. And it turns out there's really only 4 colligative properties: vapor pressure, osmotic pressure, freezing point, and boiling point. Essentially what's happening is the solute particles get in the way of the solvent particles. Now you might recall from biology that osmosis is the transfer of particles through a semi-permeable membrane. It's based on concentration. These would be terms like hypotonic, hypertonic, isotonic. When there's a difference in concentrations from one side of the membrane to the other, water molecules might move from one to the other to try to equal out the concentrations. By having different concentrations of solute, you'll get different pressure from going to one side or the other. Saying that, that's not going to be a major focus of this class. Let's discuss more in biology. What I'd like to discuss more is why would you pour stuff on the sidewalk to help it melt? And in fact, what would you pour? Well, we can pour anything on the sidewalk to help melt the ice. For communities close to the ocean, like say the Outer Banks in North Carolina, they might put sand on roads before a snowstorm. Around this area, we tend to put salt on roads. If you're a homeowner, you don't have either, you might actually put, and I've had people, friends, do this, put out kitty litter. It really doesn't matter what you put on the sidewalk, anything would work. If you wanted to, you could put out honey. Now, some things are better than others. Honey would be pretty sticky, but there are drawbacks to all of these. Salt does cause corrosion, but in this area, salt is cheaper. We can get lots of it, so that's why we salt the roads. Not because salt is so much better than something else, it's just economically better for our area. But anything would do. However, saying that, what's really important is how much you dump. You can't just go out there with a single grain of salt, put it on the sidewalk, and the whole thing is taken care of. When communities salt the roads or sand the roads, they dump tons of that onto the ground. The more you put on the ground, the better the result. The 2 colligative properties that I would like to focus on are freezing point and boiling point. You need to know that when you add something to freezing point, it will always go down. It'll melt earlier or freeze later. It doesn't matter what you add, salt, sand, kitty litter, freezing point always goes down no matter what. At the same time, the boiling point will also go up. It'll boil later and condense earlier. The net result is that anything makes a solution stay liquid longer. One of those common examples where you might see this idea would be something like antifreeze. You put antifreeze in a car to keep the liquid running through the pipes even when it's below freezing outside. It's a highly concentrated solution, typically of propylene glycol or ethylene glycol in water. And it's about half and half. It's extremely concentrated because the more you put in, the bigger the effect. This picture I have here is a marine antifreeze where you can get out into sea and get very cold. And in fact, it says it can last to negative 60 degrees Fahrenheit. So water typically freezes at 32 degrees Fahrenheit. This apparently says you can go down to negative 60 and still be liquid. Now in this area, that might be very useful for us. We might want to make sure we have antifreeze in our cars. But in other areas of the world, this product could be sold as anti-boiling. The same substance, propylene glycol or ethylene glycol, would not only cause it to not freeze, but it would cause it to not boil. Not a big problem here because we don't live in a desert, but if you did live in a desert, having a very concentrated solution of antifreeze or radiator fluid in your car would keep it from boiling over, would keep it from running out of liquid. Freezing point goes down, boiling point goes up, the solution stays liquid longer. The more you dump in, the bigger the impact. It doesn't matter what you dump in, just how much you dump in. The net result, again, if you recall a phase diagram, the solid phase is this green area over here, gas phase is the blue area down here, and the liquid phase would be the yellow area in the middle. Typically, this area right here would be the liquid, so this is where it melts or freezes. Here is where it boils or condenses, and the triple point. When you have a concentrated solution, what it tends to do is it moves this line over. It'll melt at an earlier temperature. It'll freeze a little later. Same on the other side with boiling condensation. Putting salt on the roads does not cause snow to melt, but it does allow it, when the temperature is just a couple degrees below freezing, to start melting earlier. So it changes the temperature at which it will boil, or which it will freeze, or which it will condense, or which it will melt. It doesn't actually cause it to melt or freeze, boil, or condense. It changes the temperatures and conditions at which it could. Again, it is based on amount, not identity. However, not all solutes are the same. Because ionic compounds can be dissociated, can be broken up into multiple ions, ionic compounds tend to have a bigger impact than covalent compounds because they make more solute particles. So one of the other added benefits to using salt on roads during snowstorms is salt is an ionic compound, will break up, it'll have a greater impact pound per pound than say something like sand. Downside, salt is highly corrosive, and that's why a lot of places up north might have to do undercarriage cleanings of their cars occasionally.